Right, well, folks, we've got something different. I still need to finish that Gson set off. I think we've done it, but we want to do some tests. In the meantime, this has been in for weeks because we needed to make a jig. So this is a 1991 Midland 779145. Now, we've never shown one of these because they're not actually repairable. But rather than send it back to the customer and tell them that they're non-repairable, that's probably the case to the customer's Gson. Mr. Chippie volunteered to make up a jig. So we've spent about 20 quid in parts and some time as well, which the customer will not have to pay anything towards. I bought one of these about 2014, and I put it on one side because there was nothing I could do with it. So you'll see why. Now, you look at this. The wear on the buttons, this has had an awful lot of very successful use. So it's an emergency set, which no doubt came in one of those blow moulded cases, and you can put a rubber duck aerial, you can plug in probably one of those telescopics on a mag mount or a normal aerial, and you've got external power which says 12 volts there. I suspect that it's a Maxon because it says made in Korea, and it's got the Maxon type of plate you'd expect. We've got no information whatsoever, so if any of you got an instruction book with one of these, we'd be very pleased to receive a scan of that because it would help others. And then you've got a battery thing on the bottom, so the suggestion there is that no doubt a battery thing was available to turn it into a walkie-talkie with a rubber duck. So a versatile set, and a move on from the Maxcom 7E and the Midland 77805 for us in the UK. This is just before 2781 specification was replaced with PR2794, which was the improved spec in line with Europe to enable them to allow us to have 80 channel sets. So it was always Europe that was putting the spanner in the works. We'd got no minimum receiver specification, and Europe had, and we had to do that. And so this takes that into consideration. So although it's 2781, it's got the improved type of receiver specification. Now when you open it up, this is why you can't service it. Mr. Chippie's taken all the screws out. I've no doubt he's put them somewhere. Are you ready? We have two halves of a radio, and the connectors mate up when it's put together. And so when it's apart, it isn't going to work, is it? Because the front panel is no longer connected to there. All we've got is an earth wire. So this is a 13-pin connector, and we have managed to procure some 13-way connectors, which aren't, to my knowledge, available, but we did some jiggery-pokery with our wholesalers. Mr. Chippie's made up this. So, what I don't mind doing this, because somewhere I've got one of these sets, and this will enable us to service the one from here. And we've got this 3-pin one as well. So there we are. Mr. Chippie goes to the top of the class, and then he can jump off. I don't think the customer sent a power lead with it. If the customer did, I'm sure he'll tell us when we send it back without. So what are we expecting? It says positive centre, so that's great. It says 12 volts. So that's what we'll do. Because we've got no information whatsoever about it, I'll run this at 12.4 volts. I'm not going to go any higher than that. It doesn't matter if it was mine, but it isn't mine. I don't know whether these are too loose. We'll find out. So, plug our power lead in. That felt pretty loose. tell you what, we'll change the 9-volt one to 12. Oh, for some reason the 13.8 one's should be 12. Just change that. There we go, 12 volts. Well, that's a good start because we've got nothing. Oh, that's because you have to switch the LED on. That's alright. Because I could see the power supply was drawing current. So it's one of those which annoyingly... Are we in some kind of lock mode? Something isn't making contact, which is bonkers because these are all spot on. Where's transmit on this? Right, let's get an aerial connected through our Motorola adapter. I'll switch picture in picture on while I remember, and we're showing the main meter of the Marconi test set. So I'll press transmit, and I wasn't on the test set, I'm actually on the aerial. Wouldn't be difficult to put a label on these, would it? But they come from different directions, so it shouldn't be a problem. Okay. So for some reason I can't change channel, and press transmit, and we have transmit, and the radio is doing 2.7 watts. So that's a good start. So why have we got a problem with this not receiving? Well, I think what we're going to do is we'll pop the power off, disconnect Mr. Chippie's jumper cable. These could be dirty. These are the proper connectors. You know, there's no error there. Let's just put it together. Tell you what, I can foresee problems before we even start. There we go, get the fiberglass brush. These are only tin plated pins. We'll put it together. That's not quite in the right place. Switch it back on again. So it is on the interconnect where you can... Yeah. Well, is it? May have to get some switch cleaner down those and work it a bit. We've still got transmit. Let's see what we can't change channel. Oh, it's probably because it's got a channel 9 switch. I hadn't seen that. So there I am. So I'll tell you what, in its natural state, in other words put together, So we've got this problem with intermittent. It could be dirty volume control. Something's not right. Could be a dry joint. And I'll tell you what, let's go through it right now. There might be a part 2 to this one as well, you don't know. So we're doing, let's give it the benefit of doubt, say it's 2.8 watts. .7 watts. 2.8 watts. I don't know whether these are supposed to be 4, because I don't have information about it. Lots of hand portables are 3.5, because the difference in range between 3.5 and 4 watts is virtually nothing, yet the power consumption is so much higher. So, I don't know. So it's in high power. It's got low power, so let's see what that is. It's 320 milliwatts. Back to full power, and it's 764 milliamps. Deviation on this test set, take that with a pinch of salt. Wallow, it's 1.9. We won't be doing that. And the frequency, test gear's only recently been switched on. Frequency, if we go to camera 2, .2779067. So it's probably about 0.77 when it's warm, everything's warmed up. So I'll set that pretty pronto, but we'll look at that later on again. So I'll just run through some of these other things on the... turn the volume down. We've got a power meter and it's showing 4. In low power, the power meter shows 2. It won't be adjustable, I'm sure it won't. So let's now put in 27791, whatever it was, into the signal generator. So it's exactly the same frequencies the radio is working on, for absolute fairness. It's no good me having the signal generator on frequency and the radio off frequency. Oh, 0.67. I wouldn't say it sounds nice, but I can't test the sine because doesn't have an earphone socket. So that's something we'll have to look at when it's on the test jig. I can do the squelch. Remember, this is an emergency set, so we mustn't. Mustn't get too excited over any parameter performance. 2.6. It is 260 millivolts, which is higher than I like, but it's absolutely microvolts. And the threshold, let's go back to that. Let's put the attenuator on the inset picture. We switch the signal generator to standby, parked at 0.3, and drop the squelch to threshold. Switch the signal generator back on and see when the squelch comes in. That's a not brilliant 1.3. That could cause round scratchy corner. Let's put 100 microvolts on the radio. We should have S9. That's exactly what it's showing. We'll put more signal on. We get plus 30. And as we drop the signal off, it goes off. So that is right. Doesn't have one of those. Those seem to work. Noisy. have to clean those. The sockets seem to work. It doesn't have that. That works, that works. So that's a good start. We'll take the power off. Split the radio. And put some switch cleaner on these potentiometers. Now, I can get into it through the rivets. If this doesn't work, we'll take it apart, as in the front panel. But I always try and keep costs down for customers. Let's work that in the hope it's actually gone in. So why have we got dirty connector syndrome? I'll just make sure. I mean, these are all new connectors, but you don't know how long they've been in a warehouse. So I think we're down to just the issue of intermittent audio. Power back on. So it is changing channel fine. Yeah, we can see it's working, but we've got no received audio. Oh, it's that wire off. Simply a wire off. And you can see the mark where the wire connects. In fact, there's two pins which it's kind of soldered to. So I'll just get the smouldering bat on. So there we were thinking Mr. Chippie got an intermittent joint, and he hadn't. Alright, switch it on again. There we go, that's better, and the controls are now smooth in operation, so the service saw must have gone in. Oh good, we are doing well. Yes, Mr. Tango. Right. No idea what the transmitter lineup procedure is, but we've got this insulator, which is fine there, but here covers what's clearly the transmitter. So I'm going to look for presets. I can only see one preset, and that may be exactly the one, and I expect that would be deviation. The one preset I can see is there, your VCO is there, so that would figure because it's always going to be near the VCO as it applies the speech to the varicap diode to do the frequency modulation. So we're not going to touch those. That's going to be detector. This is going to be the front end. This is probably going to be the IF, and we're going to have, it's a possibility these could be transmit, These are definitely transmit, and so is that. So, I'm not expecting to get super power out of this. It's an emergency set and a walkie-talkie. So here we go. Oh, it's time. Of course, you know what it's gone and done, don't you? It's gone to channel 9. The only thing that happens on channel 9 is farmers round here. So we're going to stay on the 3 watt. So we're coming towards full scale deflection. Just see whether we can get it to full scale deflection. I'll take that insulator out for now. If these have cores in them, that is. No, they don't have cores. So we'll just have a look whether these affect transmit. No. That's strange, isn't it? That certainly does. Got full scale deflection beyond now. I'm going to be very careful with this and look exactly where it was before, because this could be part of the this could well be the second harmonic trap. I've put it exactly back where it was. So these could well be receive, but I'll just check again. Yeah, they're not affecting transmit. I'll adjust that, but I'm sure it's in the receiver. Back to exactly where it was. I'll get a powerful torch, but I think that is it. So, where's the synthesizer? You know what, folks? I bet it's on the front panel board. Because I've got no reference crystal. I'll take it apart. So, may well be unsoldering this speaker again. This is where we hope lots of little springs and buttons don't fly out. Just to give me absolute manoeuvrability. I think we're better unsolder those right now. And there is our frequency reference. But it's not as hard as you think, because we can put the set back together and hey, look, we've got some adjustments on here. Right. Back to channel 20. There we go. So you do your presets this side, you do your tuning the other. What fun! So we can connect our test gear to one of these pins for the speaker, with the speaker disconnected. So if we've got one of Mr. Chippie's crocodile clips here, which we usually have, a nice red one, we connect that to one side of our test gear speaker connection. It's that one. Are these cracks or is it glue? That looks like a crack. So we can now get those cyanide readings which we couldn't get before. For 12 dB. We've got 1.3 microvolts. For 10 dB, we've got 1.2 microvolts. And for 20 dB, it's 10 microvolts. Right, so let's do frequency. Go to the frequency counter. Leave it at that. Power. High power and low power. I think we want a different one. So we're in transmit. Oh my goodness, there we are. So we peaked it on the coils and now it does 4 watts. Well, would you believe that? And we're exactly 400 milliwatts on the other. And our current consumption is now 1.07 amps. Let's go down the channels, or up them even. Channel 40 is 4 watts. I could say 4.01, so I will. Channel 1, 3.95. Still think deviation is going to be down there. So we've got what? These are actually labelled. So RF meter. So we want that to be just 4 on channel 20. Normally it's traditional for 1 bar to light on low power. Ain't going to do that, is it? So let's just go to low power. Got 2 bars there. 2 bars there. Oh no, it says RX meter. I'm on the wrong one. It says TX meter here. I bet now if we go to 4 we can, yeah. So just wanted to be showing the 4. Now in low power it's probably telling, yeah, that's fine. That's exactly how I like to see it. So we've messed up receive, but we'll come back to that anyway. I've put S9 on the signal generator and it should be just not showing the 4th bar, so that's fine. And then what's this? Oh, squelch. Come back to that later. So our deviation is I thought down there. I think you can possibly get to that. I'll turn the power off though. Oh, we'd all love to have these in all day, wouldn't we? Just can't tell whether that's a crack. Or whether it's just some residue like glue or something. Right, so that was a revelation. So our preset for deviation is there, so it cannot be accessed except with Mr. Chippie's jumper lead. May as well leave the front off. I'm very pleased about being able to do all that. Sorry it's on a bit of an angle, it's the only way I think we can show this. Where's my little 3-1? There we are. Power it back up. And back to channel 20. Just like that. And connect our test gear to the speaker pin, which is that one. So the first thing I want to do is the detector. We'll put the oscilloscope on, go to the right camera, which I think is camera 3. It's enough volume for a meaningful trace. Why doesn't that fit? See if we can get the cyanide right first. course I need to put this on frequency, don't I? Crystal filtered as standard. It's the biggest signal on for the IFs. Turn the signal down a little bit. Yep, they're the transmitter ones which we didn't find first time round. So transmit, we've got the lower stages here and the only other stage there. I don't know what that is yet. Don't know whether it's transmit, because or did we say that was the filter, didn't we? Let's check on receive. Well, it's certainly not a nice waveform, that. Just go through the front end once again. see how the squelch performs. So if we can improve that, squelch to full. So I want it to open at 100. So our squelch preset is that one which was there. Let's find a tool that actually fits. So that's our squelch preset to 100 microvolts. Let's put the attenuator up on the screen, and now put the signal generator as 0.3 of a microvolt and park it there. Turn the squelch down, and now we've put the signal generator to standby. Put the signal generator back on. It's coming in at 0.3. So we can hear this set down to about 0.6, but it's not a sensitive receiver. So 0.3 and 100. So as we've got this, let's see if we can get see what the deviation is on the other test set. Take picture in picture off, it's not relevant. Right, we'll have to kind of I'll take that off because we don't want to hear it. Turn it over, press transmit, there's the microphone, put the other glasses on, Wallow, it's 1.8, wow, wasn't the wrong, of course it's changed channel, hasn't it, because I unpowered it. Wow, it's 1.6 or something like that. So here's the fun. Wallow, wallow. There, we've got 2.2 now. What a faff. I'll come back to that and see if we can get anything better with the receive. Because to be quite frank, it's crummy. Right folks, we're going to bring this to a close. And hopefully we'll finish off the Giessen set tomorrow. We've already done the on-the-air test. I'm not that happy about the receive on this. It's in my opinion pretty crummy. Can't get the kind of waveform I expect from the detector, but without a circuit diagram I'm not going to start poking into it further. It works fine, but from a technical point of view, anyway, what I want to do to conclude, I just want to do the sensitivity check. So I've made out a chart. I didn't photograph the top side, but everything's labelled on the top side. So transmit deviation, I don't know where the red pen is, but I have to use the orange one. So you've got the two transmit multipliers, the earlier stages, and then you've got the power one there. But so we've peaked it, and then we've adjusted the power for 4 watts on the top board. You've got 5 on receive here, front end and the IFs. Got the detector here, the VCO which we're not touching here, and I said the transmit deviation. So for the first time ever, I've actually made up some kind of chart. I'll just make a note. It's 77. Can't even see that. 9145. Right, so that's that done. So I'll get that scanned and in my database. So in order to do the deviation for you all, seeing as we did the on the air test yesterday, we'll unplug the aerial. We'll put. So the trouble with no extension speaker is we can't plug anything into it, obviously. So we've got to faff around. Just tighten some of these screws up. Good. So what we're going to do is we're going to temporarily solder a thin bit of wire to the positive pin of the speaker so that I can put this thing together and we can do a deviation, we can do a receive check with the synapse meter. A thin bit of wire here. Just solder it to the audio hot. Let's tin the wire first. Just like that. I'll tell you what, we'll do that so it's coming out to the bottom. Need to put the insulator in. Put the two pieces together. We've got a little bit of wire dangling out to the bottom now. So, hopefully when I power this up we can plug our test gear into that bit of wire. Remembering it's 12.8 volt of 12.4 volts. There we go. Change channel. And see if when we connect our crocodile clip, we should be getting the earth return through the aerial socket. We can't do it, can we? It was alright when it was all in bits. Okay, all we can do is listen to the signal generator. Well, that's 1 microvolt. 0.8, 0.7, 0.6, 0.5. It's about 1 microvolt. Anyway, we did the on the air test. I can't. He's sorting out the audio if you try and do that. We could probably explore one of these in greater detail if it was. Well, I've got one of these somewhere. But there you go. Anyway, it's done. I think received slightly disappointing, but it works fine. We've done the 6 mile test. You can see the on the air test, and you'll find it works a treat. But the transmit's alright. We noticed there was a bit of a hum transmitted when it was on 4 watts, but there again, you see, it's not expecting to be on a mains power supply. And we use a general purpose bench power supply, not a transmitter type power supply. So there we go. So now you've seen one of these, so you don't have to see one of these again. I'll just take this link out. Mr. Chippie can screw it back together. Because he's got the screws on his bench. Well, Nana, Roger. Okay, there you have it. So thanks for watching the rather unusual Midland 779145 from 1991.